Okay, so this next section is the second part of 2.3, but it is just basically two example problems. So here's a graph, and we are going to answer all of these questions about it. The first thing to note is that this is a screenshot of a graph, so it is understood that the graph does continue down in both directions. Okay, so the first question is, what is the domain? So your far most left point is an arrow, and your far most right point is also an arrow. So this has a domain of negative infinity to positive infinity. And then your range from low to high, well, we're coming down from negative infinity. And the highest point we have is up here at 9. So I'm going to say N9, and it touches 9, so we have a bracket. Okay, and then it asks for the zeros of the function, and that's just where it crosses the x-axis, which is at -4. No, not at -4. All right, so we're going to say about negative 3.75 is as close as we can get to that, and then 7. Again, do the best that you can. Not all these numbers are going to be perfect whole numbers. Okay, so after having the zeros, we can identify where x is greater than 0. So where it's greater than 0 is this whole piece above the x-axis. So we have x is greater than 0 from negative 3.75, and parentheses because it doesn't say and equal to, all the way to 7. Then it's negative below on these 2 points. So we have the function is less than 0 from negative infinity to negative 3.75. And also from 7 to infinity. Okay, so where's the graph increasing? Well, the graph is increasing initially. So right here we have the graph increasing. And then it stops at this point right here. So from negative infinity all the way up to, I would say, what does that look like? Negative 2.5. And then at negative 2.5, we start having a horizontal line. And this is actually where we are constant. It isn't going up or down. So this is called constant, and this is new. So from negative 2.5, where it stopped increasing, to 2 is where it stops being constant. And then it starts increasing again at 2, all the way up to 4. And that's where it begins decreasing and going back down from 4 to positive infinity. And again, think x-axis. I wrote this. I'm looking at the fact that it's going up or down or staying constant, but I'm writing it left to right. Okay, so we have, it says local, so we're local or relative maximums. Well, for this one, we only have one right here. So I understand it changes directions here and here, but that's not a peak. That is not a true like mountain top, okay? So we are going to stick with just this one here, which is at 4,9. And the minimums, well, there aren't any. So we write none or non-applicable. And then are there any absolute maxes? Well, that max is the absolute max, so I'm going to write it again. And then if there aren't any relative or local minimums, then there aren't any maximum ones either. Okay, so the end behavior of the graph. All right, so if I looked at this the old way from Algebra 2, I would say, okay, down, down. And again, if you need to do that to kind of get a head start, that's fine. But you do need to be able to know the notation. So I'm gonna actually scoot down here. So as x approaches negative infinity, aka as we go left, the function in terms of x goes towards negative infinity, aka it goes down. Then we have the right side. As we go to the right, which is towards positive infinity, the function in terms of x also goes down towards negative infinity. And then looking at the fact if it's even, odd, or neither, this one is neither for the symmetry. Okay, example 2, the domain of this function. Well, this domain has an endpoint on the left. So we have a domain of -3 with a bracket because it's included all the way towards infinity, and a range, the lowest point of this range is -1.5 to infinity. So the zeros of this function are at x equals -1 and 1. So where is it greater than 0? Well, starting on the left, it is greater than 0 at the beginning. Now, it is greater than 0 at -3, so we will include a bracket, and that's because it's an endpoint and it's not like on the actual x-axis. It is clearly above the x-axis, so it's clearly positive. So -3, and then it continues to be positive until -1. And then we're going to skip over that middle piece because then it's also positive from 1 to infinity. Now, this next one doesn't just say when is it negative, but it says when is it negative and equal to 0. So between the points, the two zeros, -1 and 1, it's negative, but since it has this and equal to at the bottom here of the inequality sign, we're going to put brackets on both of those. Okay, so the first thing this graph does is increase. So it increases from -3, and again, at -3 it's doing neither. So -3 to -2.5, and then it's decreasing from -2.5 to 0. Then it starts increasing again from 0 to 3, decreasing from 3 to 4.5, and then from 4.5 to infinity, it finishes increasing. And again, you can put the little union signs in between if you'd like. All right, so the fact that I just was able to list every single interval of this graph as increasing or decreasing, it means there aren't any constant places on this graph. There's no horizontal line, so we're good there. All right, so local or relative maximum. So I have one up here and here. And those are at the point, I'm going to try to squeeze them in, -2.5, 5, and 3, 4. And then my two minimums are at 0, -1.5 and 4.5, 2.75. Okay, so are any of these absolute mins or maxes? So we don't have an absolute maximum because the graph continues up forever. So we don't have one there. And then for minimums, we do have one, and that's the one at 0, -1.5. Okay, so for the end behavior, again, I'm going to come down here for more room. So because we said this before in that one example of the notes the last time, if it ends at a point, there's no end behavior. So I can write no left end behavior, and we can abbreviate that. But as we go to the right, f of x goes up towards positive infinity. And then, to finish this problem, as far as symmetry goes, once again, it has neither.